Hello class, today we're going to talk about factoring trinomials when that a term is going to be bigger than a 1. So when we look at this, the first thing you're going to notice about this trinomial is it is a 3x squared. That's going to be a little different than the x method we used originally. But the beauty is, as we go to set up this for x method for these, the only difference we really need to worry about is before, where it was just a c, it's now an a times c, and the bottom is still going to be the middle. So the first thing we need to look at here is 3 times 5. That's going to put a 15 up top. Our b term was 8, and we're still going to work through trying to figure out what multiplies to get the top and what will add or subtract. So as we look through 15 doesn't have too many options, so we could look at a 5 and a 3. The last step here, before we can kind of put into our final answer, is there is going to be a step where we need to divide by that a term, okay? So what we're going to do is we're going to divide by that a term, so we're going to put that 3 underneath. Now, both of these fractions should be simplified. Well, that's going to be a 1 over 1. 5 over 3 is nothing. And when you go to put these numbers back into our terms, it's going to be very similar. But now what's going to happen is that 3 is going to come out front to be a 3x, and we still have the plus 5. That 1 is going to come out front and be an x plus 1. Okay, and there we are with that answer. So it should still continue to be able to FOIL to check your answers, but let's move on and look at the next one. Okay, so once again we have, we should take notice that this a term is not a 1. So what we're going to be looking at here is 5 times 2 is 10, negative 7 for our b. And then we need to look through our terms that are going to give us a times 10th and also add to get negative 7. So hopefully we're thinking about negative 5, negative 2. And of course we need to now remember this step of dividing by a. So what we should be able to do is divide both of them by 5. And before we kind of finalize our answer, what we're going to be looking to do is just simplify these terms. So this one over here becomes a negative 1 over 1. And then this one to the right side is going to stay the same. So bring those terms out. We're going to end up with that x minus 1. And then the other term is a 5x minus 2. And if we FOIL, we should be able to see all those numbers come back. Okay, our third example, we're looking at this one, and one thing we're going to notice is that going back to the first day when we looked at GCFs, this one here should be able to factor out a 2, which would leave us with a 2x squared plus 5x minus a 7. And when we look at this term, we are still looking to see if that can break down into 2 smaller binomial terms. And that's just going to be something after we get that GCF out that we still need to work through our a times c, bring down our b, and we're looking for terms that multiply to give us negative 14 and add to 5. So if we look at 7 and 2, but the 2 has to be negative. And then, of course, we always need to remember at this point to divide by a. Now, remember this one here, we did simplify down first, so we do need to divide by the 2 after we already got that GCF out. And then as we look at these numbers, that one can simplify. Our 7 divided by 2 cannot. And remember, that 2 is always coming out front to 2x plus 7. And then we have that x minus 1 for the second term. And that's what we're looking at. Okay, flip your page and look at your special cases. So nothing's really going to change here, but you will see that this x squared minus 49 doesn't have any middle term. If it helps to rewrite that, we know that that middle term is really just going to be a 0. And everything else should work as always. If we do that a times c up top, now back to when we first started them, that 1 is up there. So that really doesn't affect this one. But we still want to figure out what multiplies to get negative 49 and get 0. Well, the only way we can get to a negative 49 and get a 0 is if we get the same number that's both positive and negative. So 7 times a negative 7 is a negative 49, and 7 minus 7 is 0. And just like these other ones where we're talking about our a terms, we could divide by 1. But really what that allows us to do is bring that x out, plus 7, and then an x minus 7. And that's going to be something we're going to see from time to time as our special cases. But treat them just like normal. Just remember to put that 0 back in its place. Okay, when we look at problem B, once again, we can kind of already assume this is going to end up being some type of special case. But just put that plus 0 back in. Now this one is going to require us to do an a times c. So we can look at negative 36. When we look at 0 at the bottom, well, that really leaves us with a 6 and negative 6. With these new ones, we can't forget to divide both of these by 4. And what that's going to allow us to do is simplify both of those fractions. 1 over 3 over 2. This one would be a negative 3 over 2. And when we bring that back to our original, again, keep with that process of the 2x comes out with the plus 3, and then we will have the 2x minus 3. When you look at an x squared plus 16, what we're going to look at there, once again with our x method, is we could go back here and put in our plus 0x plus 16. Well, if we go 16 up top and x down, or 0 down at the bottom, we're going to have a little issue with this one because we would look at 4 times 4 is 16, but a 4 plus 4 ends up not being 0 and would be an 8. Well, the only way we could get 0 in the bottom is if one of these is a negative. And if we have 4 minus 4 is 0, 4 times negative 4 would actually be negative 16. So we're going to find out that this one here is not going to work. There is no possibility. This is going to be one of the ones we would be able to call prime. There's no way we can end up getting a 16 and a 0. So when you look at the special cases, when we see that plus 16, that's going to kind of hold us up a little bit. So just something to watch out for there. Okay, the last one here. Now this one looks just like a normal trinomial, but this one's going to come up as a special case because as you work through your a times c and your b terms, this one does work out, unlike the last one, where 4 times 4 does give us a positive 16 and 4 plus 4 does equal 8. Now remember, we're still kind of dividing by that a term, which is a 1, but what that really brings up is both of our terms is x plus 4. And the reason this one's going to make our special case is because we're not often going to see this x plus 4 times x plus 4 as our answer. What you're going to see a lot of times is if we have two of the same terms, a lot of times we are going to rewrite that to be x plus 4 squared. And then that's what we'll be looking for in our final answer. All right, so good luck with your practice worksheet and continue working through them. Have a good day.